Okay, we've come to 2-4 quadratic functions. It's pretty straightforward. You've done this in IM2. You should know that the basic form for quadratic is ax squared plus bx plus c. That's called standard form, and we always write it in descending order with the x squared first, then the x, then the constant term. When you graph a quadratic, you always get a parabola, and just a couple of rules of thumb on this. If a is negative, the parabola will open down, you know that. If it's positive, it will open up. And if you set x equal to 0, those drop out and you wind up with just plus c. So you can always find one point on your parabola, 0, c, by just looking at the equation and setting x equal to 0. So those are a few of the basics. Okay, I thought I'd help you with your homework here just to get you started. This is simply saying tell whether each function is a quadratic function, and then for each quadratic function they want you to evaluate it or find f of 3, f of negative 3, and our old favorite f of a plus b. Okay, and then they want you to graph it. Well, I'll help you with the identification part just to make it clear. You just simply want to know, does it fit into this form for the quadratic? Anything that's a quadratic should be able to be written as ax squared plus bx plus c. And a can't be 0, because if it is 0, it's not a quadratic, it's just a linear y equals like mx plus b. Alright, so it has to have the squared term, and it can't have anything that's higher than the second degree. Looking at this one then, f of x equals 1.5x squared. That is simply a quadratic, and it fits like this, but a is just the 1.5. Alright, so now you tell me, what about this one? Okay, make your prediction, and here's the answer. That was good. Okay, now take a look at this one. This is a quadratic if you can write it in that form. So see if there's any algebraic manipulation that you can do on this to get it into that form. Can you? Alright, let's see. Oh no, alright, there's no way that you can transform this to be written as a quadratic. When x is in the denominator of a fraction, that's actually going to be a negative exponent on that. Alright, looking over here, can we transform this to be written in a quadratic? Alright, let's see. Yes, we can. We can simply take that 5 and stick it at the end, and it's negative 7x squared plus 5. The b is 0, but you've got an a and a c, and that's okay. Number 6, what do you say there? X minus 4 raised to the third. You're right. That is impossible. Okay, now on to 7. Hey, you're right again. You FOIL that thing out, and you're going to get x squared minus 8x plus 16, and that is in standard quadratic form. Okay, well done. Okay, I'm going to do an example now, just where we're asked to graph this equation, and it is x squared minus 4x minus 12. It's a parabola because it's quadratic. This is a invisible plus sign out here, so we know the parabola opens upward. The first thing you want to do is you want to find the vertex. So the steps to do that are, the first thing you do is you use this equation you learned last year, minus b over 2a. That will tell you the x coordinate. So this is a really important equation here. I'm going to have little rays of sunshine coming off of this thing, because you should memorize that thing. That is your friend, okay? Very helpful. Minus b over 2a, okay? So if I do that, minus a minus 4 over 2 times that invisible 1, that's the coefficient right there, that's going to just give me 4 over 2, which equals 2. So my x coordinate then for the vertex is 2. Okay? Step 2 then is to plug this in for the x in the equation and find the y value. Or really, since it's in f of x form, we'd say that's f of minus b over 2a. Okay? Well then, when I plug 2 in, I get f of x is equal to 2 squared minus 4 times 2 minus 12. This is 4 then minus 8 minus 12. That's 4, negative 4 rather, minus 12 equals negative 16. So the coordinates for my vertex then, which I would write on my homework, would be 2, negative 16. Okay? Well then I will go over here to my graph, and quite often you need to condense your y-axes a little bit. So I've made that to be positive 20, negative 10, right, negative 10 right there, and negative 16 over 2 would be about there, and then down negative 16. There's my vertex. And then as I showed you before, when we have x as 0, this will drop out and we get negative 12. So it's going to cross right there at negative 12. And I know that on this side, that vertex is the lowest point, and it opens upwards going like that, passing through that point, 0, negative 12. Well, I know that parabolas are symmetrical, so I can make my dotted line there. That's my axis of symmetry, and I'll get a matching point called the symmetric point that is at 4, negative 12. All right, now how did I know it's 4? Because I'm going to positive 2 from 0 to get to that line of symmetry, and so then I just double that amount, and 2 doubled is 4, so this is 4, negative 12. We'll go over this in class. It's not absolutely critical that you understand that at this moment, but that is an easy way to graph that parabola. Okay? Okay, I want you to look at this problem in the book on page 96. It's appropriate for Pingree because it's a lacrosse ball that's being thrown by a girl from a height of 7 feet, it says right here, and at an angle from the horizontal of 30 degrees. And you can plug these parts into this sort of standard equation for a ball being thrown on Earth. It's the height of the ball based on the time it's aloft. This is the effect of gravity on Earth. It's a downward force. It's negative 16 t squared. On the Moon it would be less. On another planet with higher gravity it would be greater. But here on Earth it's negative 16, and that's for feet. All right, it's 4.9 for meters per second, but this is in feet. And then we've got the initial velocity here. That's the speed with which the ball is thrown. We've got the sine of the angle. The sine is the vertical component in our trig ratios for a right triangle that's oriented like this. And it'll change from problem to problem, but right now it's the sine of 30 degrees and then plus the initial height. So even though these parts all at once can look pretty complicated, you can break it down and plug in each part separately. And then they take you through the problem here and they plug in all of those things, and then they wind up with this equation right here where they've plugged it in, and they've got negative 16 t squared. 90 is the initial speed of the ball, and that's in feet per second. And then they've got the sine of 30 degrees, which is 0.5 when you plug that into your calculator, and then 7 is the height. And so you wind up with a quadratic that then they're asking you to analyze, and they're trying to get you to answer to find the point or points at which the height is 25. So we plug in 25 and we set that equal to this equation, and then we solve it.